Hi everyone. I was asked to make a couple videos to make our learning a little bit easier for you. So I'm going to do that. I'm going to start with this week's lesson, Nonlinear Relationships, Block 3. So we'll jump right into that, and then I will make a video for Block 4 as well. So on Block 3, though, on weekends, Austin helps his uncle with his landscaping business. His uncle builds outdoor areas such as parks and neighborhood yards. Austin's favorite part is building patios with large bricks and tiles. A client wants Austin's uncle to design a triangular-shaped patio made of triangular tiles. Austin's uncle needs to know exactly how many tiles to buy because the project is on a precise budget. He asks Austin to figure out how many tiles they will need. Austin asks, "How big should we make the patio?" His uncle says, "It's hard to answer that question because the client gave me some possible length measurements, but not the number of tiles. Why don't you make a list of patios of different sizes, each with the length and perimeter as well as the number of tiles that we will need?" So Austin decides to make a table that lists the length, the perimeter, and the number of tiles for various patio sizes. Play the animation to see him organize the data. So he's going to draw a picture of the smallest patio he can make, which only uses one tile. Then he'll fill in the measurements in the first row. So a patio length of 1. The perimeter then, the process was to add 1 plus 1 plus 1, or 3 times 1, because each side is only 1 and there's 3 sides. So the patio perimeter becomes 3. And then we just used only 1 tile. Then if we add a patio length of 2 tiles, now if you see this right here, the patio length is only 2 because there's 1 going across here and 1 going across here. There's more tiles than there are the length, but it's only 2 because there's only 2 sides in a row. So then we could do 2 plus 2 plus 2, or 3 times 2. So our perimeter then we get 6. Now this is where it changes. The number of tiles become 4 now instead of 2. Even though the patio length is only 2, the number of tiles is 4. So it says down here, this patio has a length of 2 units and a perimeter of 6 units. The number of tiles has grown by 4, grown to 4. Then again, if we put a length of 3, 1, 2, 3, then the perimeter becomes 3 plus 3 plus 3, or 3 times 3. So the patio perimeter, if it's 3 times 3, becomes 9. And the number of tiles, if we count, become 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. So there are 3 sides, and each side there are 3 sides, and each is 3 units long. So the perimeter is 3 times 3, or 9 units long. He counts the number of tiles total needed and gets 9 tiles. Now feel free to stop and pause this video if I'm going too fast or if the video is going too fast. You can pause and play as fast or as slow as you'd like. All right, so we're going to continue building triangular patios and completing the table of values. What patterns do you see? So it looks like 1 is 3 sides times the length of 1, gave us 3, and the number of tiles was 1. 2 was 3 sides times length of 2. That was 6, and the number of tiles was 4. 3 sides times the length of 3. So 3 times 3 is 9. This one also has 9 tiles. And 4, 3 sides times the length of 4 gives us 12. 3 times 4 is 12. And then the number of tiles would be 16. So I'm guessing 5 would be 5 sides times the length of 5. Or 3 sides lengths of 5, sorry. Then I know that I could get the patio perimeter by doing 3 times 5. So I know 3 times 5 is 15. Now, if I'm going to look at this pattern here, it goes 1, 4, 9, 16. Well, I'm going to look at this row and this row. I see 1 and 1, 2 and 4, 3 and 9, 4 and 16. What that tells me is that I am squaring each of these numbers. 1 squared, or 1 times 1 is 1. 2 squared, or 2 times 2 is 4. 3 squared, or 3 times 3 is 9. And 4 squared, or 4 times 4 is 16. So for number 5, my pattern then would be 5 times 5, or 5 squared, which gives me 25. Finally, number 6, this one looks like it's going to continue the pattern. So it will be 3 sides times the length of 6. Then 3 sides times 6 gives us 18. And then 6 times 6, or 6 squared, is going to give us 36. Now this is answering question 1. If you see up in the top right corner, this would answer question 1 on your packet. Now make a graph to show the relationship between patio length and perimeter. Make a second graph to show the relationship between patio length and the number of tiles. So if you're going to make a graph, your graph should look something like this. If you can see, the perimeter looks like it's going in a straight line. The patio length, though, doesn't look like it's going in a straight line anymore. It looks like it's kind of curving up. So I wonder which one of these is going to be linear and which one of these is going to be nonlinear. Looking at these two graphs, how are they alike and how are they different? Record your thinking before moving to the next page. So again, this is now question 2. Up in the right-hand corner, it says question 2. How are these similar? How are they different? Well, like we said, this one is going in a straight line. And this one looks like it's curving a little bit. So it looks like this one here is the linear one because it has a line. This one is the nonlinear one because there is no straight line. Now it looks like to me they're similar because they're both increasing. They're both going up. They are both dealing with patio length. They're both looking at things that have to do with the tiles. Anything that you want to put that makes these two similar is fine. One way to compare the graphs is to imagine that a line goes through the points. In the first graph, you can draw a straight line through all the points. Since a straight line can be drawn through the points, you can see this is a linear function. So if we look at this, this is a linear function. We can draw a straight line through there. The graph on the right represents a nonlinear function because it's not a straight line. See, not a straight line, non-linear. It takes a curve to intersect all the points on the graph. In this graph, the number of tiles increases at a greater rate from one point to the next point. The points are farther apart vertically as the patio length increases. So from 1, it went to 4. Then from 4, it went to 9. And from 9, it went all the way to 16. It's increasing by a greater amount every single time. That's what makes this a nonlinear function. It's not going up the same amount every single time. So study the tables again to see how the values change. Complete the puzzle to explore how the patterns are similar and how are they different. Okay, so if we look at the perimeter, we have 1, 3, 2, 6, 3, 9, 4, 12, 5, 15, and 6, 18. So we're going to look at how they change here. Well, between 3 and 6, I see that it's adding 3. So I'm going to move the adding 3 there. Then from 6 to 9, it's also adding 3. From 9 to 12, still adding 3. 12 to 15 is plus 3, and 15 plus 3 equals 18. So all of those are plus 3. Then, when we're looking at this, 1 plus 4, well, that's still adding 3, so we can put that there. 4 to 9, well, that's now adding 5. 9 to 16, well, that's adding 7. 16 to 25, adding 9. And 25 to 36 is adding 11. So it looks like the pattern here is that it's increasing by 2 every time here. We have plus 3, plus 5, plus 7, plus 9, plus 11. Sorry, we can go back here. This was question number 3. Remember, this was question number 3. All right, question number 4. Another way to tell the difference between a linear function and a nonlinear function is to examine the patterns in the input and output values. In both tables, the patio length column is the same. The numbers increase by a constant amount. In this case, they increase by 1 unit. If you look at the perimeter column on the table on the left, the numbers also increase by a constant amount. In this case, they increase by 3 units. In the number of tiles column in the table on the right, the differences between consecutive values change. There's not a constant change. The difference grows as the number of tiles grow. So 3, 5, 7, 9, and 11. How does the type of change in value relate to the type of function? Well, when the amount of change in the input column remains constant from value to value, the amount of change in the output column remains constant from value to value, the function is linear. When the input remains constant, but the output does not, the function is nonlinear. Here it says create an equation that shows the perimeter for any length. Use t to represent the perimeter and use n to represent the length. Drag the symbols and numbers to create the equation, then click the check button. You may leave some slots empty. So here it looks like t equals, and it's still going up by 3 and 3 and 3. So what's happening, it looks like, is 1 and 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So it looks like we're timesing everything by 3. So we get t equals 3n. Now, if we look at this one, we have 1 and 1, 2 and 4, 3 and 9, 4 and 16. Like we said earlier, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16, and so on. So it looks like our equation is just t equals n squared. All right, so I want you guys to go through the rest of this on Agile Mind. Finish up the packet. I've given you a good start here with this video. Remember to go back and pause if you need to, or just watch it through. Thanks.